Hello. Hello. Students must come in time. Please ensure that all of you are writing your roll number and the section. All of you write your roll number and section, please. Okay. And I want to tell you that some of the students are actually not attending the classes properly. Okay, it is observed. So I want to convey this message to you that those students who are not attending the class properly, they might fall in trouble. Okay, and maybe some serious consequences may happen. Okay, because actually the college is asking for all those students roll numbers and the sections and the name, those who are not attending the class properly. So if there are any student who doesn't do the classes, any classes properly, then please inform them so that they will do the further classes. Otherwise they might fall into some trouble. Okay, just that thing is a very crucial thing that is actually discussed. Okay. Okay, still now 41 students have joined. Mm, so I think three sections are there. So more than that will be joined. Anyway, we will actually track your attendance who have joined, because everything is get logged, your chat history. So as you are putting your roll number and your section, it will get logged, and we will then analyze that who are the absents. Okay, so maybe you just inform all those students who are not are unable to do the live sessions. Okay, so I just want to start now because time is very short. So today's discussion in continuation with the previous class. Let me cover the structure as a whole, along with the structure pointer and the self-referential structure. So today we will mainly focus on the structure, how to create the variables, how to create the structure pointers, how to create the self-referential structure, and what are the use of self-referential structure, that is. Okay, parallelly after that I will just cover one thing that was left over in the previous class, that is the real function, that how you can actually use the real function, okay, in dynamic memory allocation. Okay, so today's topic is something like that. After that, if time permits, we will go for the functions. Okay, so basically as we deal with the structure in the previous class, we are actually taken or we considered a fundamental idea about the structure. That structure is basically used as a user defined data type. Okay, so this is something like this we have defined in the previous class, like using type def keyword, type def struct is, then within that we consider roll number, integer, character grade, and float marks, which are the member variable of the structure. And finally we have created this that particular name, that means just kind of a renaming of the structure from a struct s to student. And finally we have created some couple of variable. Okay, now how we can create the variable? We can create the variable like this: student s. Okay, so this was already been discussed so far, that how you can actually create the structure and the corresponding structure variable. Okay, now as we consider that structure is basically a collection of different predefined data type, and as a whole it is considered as user defined data type. So we can say that this int roll, this char grade, and float marks are basically the member variable. Okay, and the student s, whatever declare you are over here, is basically known as the structure variable. Now mind it that when we declare the structure variable, it is the memory allocation that do occurs within a particular structure is basically the total number of variable that has been used for a particular structure. Okay, so something we can consider like this in case of an array, whatever we have done. Some contrast with that, there have been the utility of the structure variable that we can observe. Okay, so just on the board here. Okay, so just whatever I've just defined is something like that, that if you are creating a structure, the variable or your memory space is something looks like this: a box consists of three different data items. First one is your int, second one is maybe float, and third one is char. Okay, So these are the three variables. All together it will be actually created. Okay, and the memory allocation is also actually considered as a pair, kind of a sequential memory allocation that is actually happening over there, right? Now when you create the student S means the whole structure or whole memory allocation as a whole is representing the structure variable itself, and each and every individual member variables are actually here is considered as the different memory cells, and when you store the data will definitely stores into the different memory cells as well. Okay, so that is the formal architecture of a normal structure variable, whatever you define. Okay, now Arnav, you are telling that actually we give it the structure gets over something like this. I'm not clear. Your point is not clear. Please, you do ask. Instead of struct a student. No. You are actually get confused. See, I am actually trying to tell you that the basic definition of the structure will start with this struct s definitely. Okay. If you write only this part, then it is also a structure. But what is our intention is to create a new data type. So what you need to use this type def keyword first, and after that we are writing student. Okay. Now actually what happened, this struct s entirely will be replaced or renamed by this student. Okay. So now we can consider the student is basically the new data type, and s is basically the variable corresponding to that student. Okay. So type def keyword, the purpose of use of this type def keyword that Orithro is telling that why it is type def keyword, type def keywords is used. The purpose of type def keywords is something like that you are actually try to rename the entire structure into a single name, so that you actually there is no use of repetitive use of or repetitive usage of the struct s keyword again and again. Okay, so instead of just bypassing that entire thing, we actually do or actually rename the structure by student, and then we are using or create the variable. Okay, and it is look very fine. Okay, it is something looks like your if you write int x, so it is something looks like similar. The student is the data type, s is the variable. Like int x, int is the data type, x is the variable. Okay, so that's why basically we prefer to use type def. Mind it that whenever you create the structure, try to use a type def struct instead of normal structure. Okay, so that is the thumb rule that we should maintain. Anyway, so now we are having the code that how you can actually create the structure in C. Now in C basically we need to do is something like this, that we have to use that particular stdio.h is common to all, and after that we are just creating this type def struct s int roll float marks char grade. Okay, so that is our structure definition. Now in general what we do, in general we will actually create the global declaration of a structure. Okay, outside of main function we are declaring structure, it means that it is basically a global declaration, right? So you have to create a global declaration like this first of all. Okay, type def struct s, then within that you have to write your member variables, right? Then you have to rename the structure by student. Okay, now in the main function C I am creating student s, that is it is basically s is basically here is the variable of the student type. Okay, now our main objective after creation of this particular student structure variable s, our main intention is to store some data into the member variable. Okay, so how we can actually do the or store the data into member variable? By using the members. That means all these member can be stored, because since I have already told you that each and every members there are separate spaces are there, so definitely you have to access all these member as well. Okay, so how to actually access those members? Those members can be very easily accessed by using our operator that is known as the dot operator here. Okay, so we can basically use the dot operator in order to access any member of the structure. Okay, so s dot roll is actually signifies the roll number variable corresponding to your member, structure member. S dot marks actually signifies the marks variable corresponding to your structure variable s. Okay, and same way grade variable by using s dot grade. Okay, so you can directly assign them like this. First of all, after doing this, what you can do, you can do just print all these values. Okay, so directly you can do this in dev C++. I've done this in dev C++. You can use any other compiler. Okay, maybe GCC. So let's try it again first. First of all, you try to execute this. So just compile it first. Okay, done. Then run. So you can see here are the outputs: 10, 87.5998 and E. Now sometime it may be asked that I am giving 87.6, but it is why it is giving 87.599, because see, because it is basically depending on the compiler. Some compiler you just consider the entire thing. Some compiler maybe convert it into up to the 8 or 9 decimal place and then show it. Okay, so 87.5998 means actually it is equivalent to 82.6. Okay, so that's why don't confuse with that. All right, so this is the initial definition that how we can actually do a structure. Okay, now mind it, you can like this, as you are taking all these variables or you are printing all these variables like percent a, d, percent f and percent c. You can take that structure variable or the member variable in the structure as well. That can be easily done also. Okay, so what we can do, we can simply write ampersand of s dot roll, ampersand of s dot marks and ampersand of s dot grade like this. Okay, so that can be done to access the data members into the structure. Okay, so this is the first thing that I want to share. Next thing is that it is basically one of the important thing is that as we can create normal variable for a structure, by the same way we can also create the pointer variable corresponding to the structure as well. Okay, so structure pointer is a pretty important thing which you need to understand, because if you want to create the data structure program, if you want to create the program of linked list, then definitely you need to have an idea about that, how you can create or how you can use the pointer. So if I write, instead of writing student s, if we write stars, then what will be the result? It is simply that you are intended to create a pointer variable of the structure. Okay, so you can use the structure pointer variable. Perhaps you can store the address of any structure variable into the pointer variable as well. Okay, so what we can say we can say something like that. I am using like this: student star s and s1. Now can you tell me what is star s and star s1? Star s is what? Star s is basically a structure pointer. Now tell me what is s1? What is s1? S1 is a pointer or S1 is a normal variable? S1 is anyone from the class? S1 is a pointer or S1 is a normal variable? S1 is basically normal variable, not star S1. Oh no, not star S1. It is only S1 I am telling. S1 is a normal variable, but star S is the pointer variable. Okay, so what we can do something like this. If we write s equal to ampersand of s1, is it correct? Is it correct? S equal to ampersand of s1, is it correct? Yeah, and Dorothy is also telling s1 is a normal variable. Orithra is also telling. Yeah. Acha. Now what is happening if we write s equal to s1? It is one of you are telling it is type error. No, okay, yes sir, okay, fine. So s equal to, if we write s equal to s1, it means that you are extracting the address of s1 variable and storing into s, that is the pointer variable. Okay, so we can do this simply like similar like any other variable. Okay, you can just take the structure variable, address of the structure variable, and store them into the pointer variable. Okay, so that can be done also easily, very easily. Okay, so we can go for this particular thing, as well as another very important thing that we are crucially do in order to create the linked list and all these stuffs, that is the dynamic memory allocation with the pointer variable as well. Okay, so we can use structure variable, structure pointer variable to store the address of any other structure variable, as well as we can also use the structure pointer is to allocate the dynamic memory against it. Okay, so in the next example I'm just going to demonstrate you something like this. Achha, but before that, I think before that I simply create a very basic S1. That's the previous one. Okay, so suppose I am writing this now. Okay, for the time being, just forget about this line. Just concentrate on these two lines. That's what we have already done in the previous example. Now what I can do, just do like this. S is equal to end of S1. Can I do this? Definitely I can do this. Okay, after doing this, now I just scanning the data and just try to scan the data. Okay, and after that I just try to print all this data. Okay, so what would be the result? Achha, before that I'm just writing another line, printf take. Okay, okay, then let us check that what will be the data. Okay, so compile it. Okay, fine, then run it. So it will prompt for take. So there how many data will be there? There are integer, a floating point, and a character, right? So integer say 12, floating point say 77.66, character say a. Okay, so data will be get displayed. The data is 12, 77.6604 and a, right? So this is the demonstration. Now our question is that how does we generally access by using when you are using the pointer. Okay, see, the syntactically there are certain differences that. Okay, so what are the difference? Just I'm just going to tell you. Structure is okay, previous structure and this structure is same, only the difference that you are making a pointer variable. Okay, and after that what we are doing is equal to ampersand of S1, that is storing the base address of your structure S1, structure variable S1 to the structure pointer S. Okay, after that if I want to scan the data element via this structure pointer variable S, then what should I do? I should write this arrow operator instead of writing the dot operator. That is the key rule that you need to understand. Okay, because see, when you are using structure pointer, it is basically the system will parse it in a different way rather than in a normal variable. Okay, so whenever you are using only variable, you may use dot operator directly. Okay, but as you are actually use the structure pointer, it means that this S is actually act as a reference variable corresponding to your entire members. Okay, so since it is a reference variable, and in order to access the data through the reference variable, this particular arrow operator is actually used. Okay, so that is the use, or that is the main key point in this case. Okay, that whenever you use structure pointer and then want to access these elements, that means your role, member marks or member grade, you have to use this arrow operator. Okay, now if we use say S1 instead of this, then what should we do? Then definitely we have to use dot operator. Okay, Achha, in this context Oritro is telling no. Okay, hello. Can you hear me? Due to some problem, I think streaming has been stopped from my side. So now can you hear me? Hello. 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 Can you hear me? Basically, the stream has been stopped from my side, so that's why I'm telling you. Okay, now it is again coming, so I can go for further. That is, in the second case, what we can do, we can have the dynamic memory allocation against the structure. Okay, so I just make this stop and open this particular port, right? So now what you are doing in this case, I can say that you are actually want to or try to make a dynamic memory allocation against the structure pointer. Now it is pretty important thing that how you can actually make the dynamic memory allocation against the particular structure. Okay, so what we should do, as we know that malloc function is mainly used for the dynamic memory allocation, so therefore we can easily create the structure by using this, or structure memory by using a dynamic memory allocation concept. All right, okay, so now can anybody tell me that what will be the operation that is going on over here? See, basically this operation is nothing but similar with the dynamic memory allocation that we have already done in our previous session. That is something like creation of a dynamic memory and against the size of the variable, and whenever you are creating the dynamic memory, it will basically return a simple address which is a void type, and you have to typecast that address against this. Okay, so just a minute, I'm just watching that whether it is fine or not. Yeah, it is fine. Okay, so now we can consider that our program is actually consist of this dynamic memory, and which has been allocated against our pointer s. Okay, so instead of writing or instead of assigning the variable directly, you can also assign a dynamic memory against a structure pointer as well. Okay, so that is the main objective of this particular program. Okay, so you can again run this, compile it, then run it. Again I am taking say 34 99.7, then say O. Okay, so it is basically kind of a demonstration through which we can consider or we can observe the dynamic memory allocation against a structure, right? So this is the second part. Okay. In the third part, we can go for another very important structure concept. Okay. Acha, if anyone have any doubt or any confusion, please let me know. Okay. I am not getting your any response here. So first of all, make sure that all of you have are seeing me or not. If it is so, then please response. Otherwise, I could not understand that whether you are actually seeing me or not, right? So please make sure that all of you get this, because in between there are some interruption was there, so that's what I'm telling. Anyway, so the next part, self structure, self-referential structure. Okay, this is also a very important concept where you can go for a structure which actually refers to itself, and it is known as a self-referential structure. Now, what is the advantage? Acha, someone is asking you the arrow part and the malloc part. Okay, I will explain it later on. Okay, first of all, I've just tell you some basic thing about the self-referential structure, then I will do that. Okay, so anyway, so self-referential structure is a pretty important concept in the structure. Why? Because by using self-referential structure, one can refer to itself. That means one data type can refer to a same kind of data type, or you can say one single data type can store the address of another data type. Okay, so this is the main concept between, or main concept behind that particular self-referential structure. Okay, so I will go further into self-referential structure, but before that I will give you some answers. Dorothy told that sir, could you please explain the arrow operator? Arrow operator, see, arrow operator is a special type of operator that I've already told you that if you are using arrow operator, it means that you are actually using the structure pointer to access the member variables. Okay, so if you are using structure pointer in order to access any member variable of any other structure, or maybe you are try to access the member of a dynamically allocated memory, then definitely you have to use arrow operator. If you are having only a normal structure variable, then what you should use to access the member variable? You have to use dot operator, that is structure variable name dot member variable. But if you use structure pointer in order to access any members of that structure type, then definitely you have to use arrow operator. Okay, so if you write s equal to arrow ampersand of s1, then definitely through s you may access your member of s1. So in order to access that particular thing, you have to use arrow operator. Okay, so that is the thing. Acha, Devjit Banerjee, you are telling about the malloc function. Okay, so see, in the second case that we have already told you that malloc function is mainly used for dynamic memory allocation, and since structure is also a data type, you can also create the dynamic memory against a structure variable too. But what we need in this case? You need a structure pointer here. Okay, so you have a structure pointer, you have to, if you use this structure pointer, then you write student star malloc size of student. Now in the previous class I have already told you that if you write malloc function, then definitely you have to create the data type, something like int star malloc size of it, that we have discussed in the previous class. So here what we are using? We are using student data type. That's why I am writing student size of student. That means total type, total memory that has been allocated by that particular student data type will be returned. Okay, and whenever it returned, it will be also again a void pointer. So you have to explicitly typecast it by using this student pointer, right? So that is the student star malloc size of student. That is the main explanation that why should we use this student star typecasting. and why should we use this size of student? Okay, because whenever you use malloc function, you have to explicitly mention the size of the data type, as well as you have to explicitly typecast your pointer or memory area into the target pointer type or your target data type. Okay, so that's why you use this. Alright, after that we can go for the self-referential structure again. Now we have an example that how you can actually create the self-referential structure. Now just look into this particular program. This particular program is basically the demonstration that how you can create a self-referential structure. Just look into this particular point. Type the struct s. Within that there are two variables. One is int data and second one is struct s star next. Mind it, struct s star next. Basically this particular declaration is a declaration of a pointer variable of the same structure within the body of the structure. Mind it, it is the declaration of the pointer variable of same structure within the body of itself. Okay, that means what? You can consider or you can say that I can store the address of the same type of structure variable into this particular structure. Okay, into this particular structure. If this is the case, then we can say that this particular structure variable is actually known as, or this particular structure is known as self-referential structure. Okay. Okay. So Acha Devjit, you are telling one question. I'm telling you that I understand you what you want to know actually, that whether it is separate memory space or not, but mind it should be always a single memory space. Okay, they were telling that whether it is separate memory space or not for each and every member variable, I guess. So if it is the case, if it is your question, that I'm telling you, no, whenever you are creating a member variable or when you are creating a structure variable as a whole, it will be a single variable only. Okay, anyway, so now you can consider this particular main function. Okay, int main. Just look into this part. Okay, int main. Within int main I am writing student star h star s1 and star car. Achha, 1 minute. Student star s star s1 and star car. Okay, student star s star s1 and star car, right? So star s is a structure pointer, star s1 is another structure pointer. Okay, now for the time being I just forget about this star car. Okay, so first of all consider star s, then we consider star s1. Okay, now what is our intention in this program is to store or is to dynamically allocate the memory against both of the structure pointer s and s1. Okay, so first line, if you consider first line, you can easily understand that basically a single memory of the student type of data will be allocated into s. Okay, in the second line s1, what is happening? Another dynamic memory is allocated to s1. Okay, now can you tell me what are the different subdivision of this memory? It is completely depending upon the member variable. Now how many member variables are there? 2 member variables are there, so there must be subdivision of 2. Okay, so if I draw the picture of this particular thing, then it is something looks like this. The first one, this, the second one is this. Okay, sorry for the bad picture, s and s1. Alright, now see, there are 2 subdivision for s, there are 2 subdivision for s1 also. First part is your data and second part is the next. Okay, it is also data and it is also next. Okay, So this is the configuration that is actually created by you as you are creating the structure part. So this one, alright, S equal to malloc size of student, S1 equal to malloc size of student. Okay, that means what you are creating, you have created these two nodes. Alright, now what is your task? You just take some data over there. Okay, so printf, then you are taking s dot arrow data part, s1 arrow data. That means for both of the structure variable or structure memory, you are storing some data. So what is going on? Suppose for this particular part, suppose you are storing say 5. Okay. For this particular part, suppose you are storing 6. Okay, so this will be stored, these two part. Alright, after that, now concentrate on these two lines. These two lines are actually pretty much vital. Okay, what you are writing, s arrow next equal to s1 and s1 arrow next is equal to null. S arrow next equal to s1, s1 arrow next equal to null. Okay, so if you write s arrow s1 next equal to s1, that what you are actually intended to do, you are try to store the address of s1 to the next part of s. You are trying to store the address of s1 into the next part of s. That means what is going on? Suppose this is the next part. Suppose s1 having address say xy. Okay, suppose the s1 having address is xy. So what this code will do, what this code will simply, this particular code, that is s arrow next equal to s1, this particular code will do what? It will simply copy xy over here. Alright, and finally what you are doing, s1 arrow next equal to null, s1 arrow next equal to null. That means what? That means the next part of your s1 pointer is null. Now for the sake of simplicity, I am defining null is 0, so basically this will be null. Okay, so that means what is it? It is null, kind of null. That means it will be stopped here. Right, so what is the ultimate objective of this particular code? In this particular code is actually stores the next address into the next part of the previous node. That means if we consider this s1 is a node and s is a node and s1 is a node, so I am storing the address of this s1 into the next part of this xy. Therefore I can say that there is basically a virtual link between this particular direction. That means from s to s1 there is a link. As we know that the address of the next node, so I can say that I can traverse from s to s1 now. Okay, so this particular structure here, whatever you are creating by using this self-referential structure, is basically nothing but a concept of linked list. This particular structure is basically nothing but a concept of linked list that you are actually going to represent. Okay, so this is one of the simplest way that through which you can actually realize that how you can use the dynamic memory allocation with the structure pointer, and perhaps you are intended to create a linked list like structure, right? So here it is created null. Okay, now after that you may create, or you may traverse your entire data sets. Okay, so for that I am using the current pointer where I'm storing this particular that address of s first, and I'm taking a loop while current is not equal to null, then just printing all the data element of the all this corresponding nodes actually. Okay, so if we run this code, you can easily understand. Just take 2, 3, then 4. Okay, so data 3 and data 4 will get printed. That means you are actually trying to create two nodes or two variables and then make a link between each other and then try to access the first node data, and from that first node you are going to the second node and then also print the data for the same. Okay, so this is the objective of this particular program, and which is, it is only possible as you are using the self-referential structure. It is never been possible if you use only a single linked list. Okay, only a single structure variable. Okay, so this is the essential component if you want to create the large data structures. Okay, so that's why I'm actually want to tell you this is a pretty much crucial thing. Okay, so you have to understand that what is a self-referential structure. Self-referential structure basically has a power to store the address of itself. Self-referential structure is having a power that can able to store the address of itself. Okay, so that is the main objective of the self-referential structure that we mainly do or mainly used to do in order to create a data structure like linked list or maybe sometimes tree also. Okay, so I hope it is understandable for you. আচ্ছা দেবজিৎ কি বলছো স্যার এইভাবেই কি লিঙ্ক লিস্ট করে? হ্যাঁ এক্স্যাক্টলি it is basically it is the entry point of linked list. Okay, this very concept is actually useful for create any kind of linked list. এখানে যেটা হলো, এখানে basically কি হলো, in this case we have created two nodes basically, S and S1 considered as nodes. Okay, we can create even n number of nodes, maybe S2 S3 S up to Sn. So you can create it like this, simply like this. Okay, so this is basically the entry point of creation of the linked list, right? So this is one of the pretty much useful example of the structure, and maybe hopefully I can share this code to you also so that you can easily understand, but try to do this by your own. Okay, you just make a snapshot of this particular code and then you can try to run this code by your own so that you can easily understand that how you can create a linked list like structure by using your user defined data types, right? So this is one of the important. Acha, any question you have till now? If you have the question, please feel free to ask me. After that I can go for another part. Okay, so yeah, definitely Indrash is telling I will try it at home. Definitely you just try it. Okay, just go for it. Okay, just try to do a basic linked list, right? Okay, after that another thing that is left over in the previous class, that is your realloc. Okay, realloc function. Now can anybody tell me that what is realloc function actually? Realloc function is a very important function. Now realloc function is basically used to reallocate the memory from one particular existing memory area to a new memory area. Okay, perhaps you can enlarge your memory or you can squeeze your memory as per your requirement, right? Realloc stands for reallocation. Prem Prakash is telling, Devajit is also telling, used to reallocate the memory. Yes, Arnav is also telling. Very good. So how do you actually make a code of realloc? That I want to tell you today. So just see this particular code. Now, this particular code is basically a demonstration that how you can actually use malloc function, realloc function and the free function, or alternatively you can use malloc and calloc as well, right? So you just take or make a note of this code might be. So what it is actually going, you are creating stdr.h and stdlib.h definitely. Now one thing I want to tell you that if you want to create dynamic memory in GCC, you have to use malloc function. Okay, that is written here. Okay, so instead of stdlib you have to use malloc for GCC. If you are using dev C++, then you can use stdlib definitely, right? So now see here you are using star p and star p1, 2 pointers. All right, This is star p and this is your star p1. Now what you are doing in the initial case, I am creating a single array. Okay, now can you tell me what is the size of this array? You can easily understand from this line that what is the size of this array. Here the size is 3, okay, because we are writing what, 3 into size of int. Now malloc function actually allocates the memory in the block wise. So if you write only size of int, so it is a single block of memory. If we are writing 3 into size of int, then it was a 3 block of memory having each and every memory block is of integer data type, right? So this is the function that has been done by the malloc. Now alternatively, you can also use calloc in this line. Okay, now if you write calloc, then definitely there are two parameters. First parameter is the size of the block, and second parameter is the size of the data type. Okay, so this is number of blocks and this is the data type size. Okay, so if you do this, any of this, then actually a 3 block of memory will be allocated, right? Now after doing this, I can take the data by using a simple pointer arithmetic that is already known to you, I think, so don't bother about this. Then scanf %d p plus I, it will take, it is there is no use of ampersand because p is a pointer. So you can take the data, you can print the data. All right. After doing this particular thing, if you write say p1 equal to int star realloc p comma 6, then what will be the result? See, where p1 is basically another pointer variable. Okay, so realloc function basically having two parameters. First is the old data or old block of memory in a form of pointer, comma the size, new size that you want to create. Okay, so here old block of memory is the p pointer itself, and 6 is the new size that I actually going to create, right? So since we are doing this particular thing, it will immediately reallocate the memory from 3 to 6. Okay, so resizing has been done from 3 to 6. Okay, then what you need to do, you need to understand that what will be the internal result will be there, or what the internal memory manipulation is there. Since 3 block of memory is already reserved or already previously there, so what it will do, it will never tamper the 3 block of memory. Only it will create what, the 3 additional block of memory just alongside of or beside of that particular array. Okay, that means 3 existing blocks are there, as well as 3 additional block will just get added. Okay, like the compartment of train. Okay, so previous data will be also there, remain persist, only the new blocks will be added. Okay, so if I pictorially show this thing to you, it is something looks like this. Say there are something like this, a memory corresponding to this. This is suppose p, and I am storing say 1, 2, 3. This is the initial memory. Okay, now suppose I am creating the reallocation or I am creating the new memory. So what will be the result? It will be definitely increased by 6. Okay, it will be definitely increased by 6. It will be definitely increased by 6. New memory p1. Okay, the previous areas or previous locations will be remain intact. Okay, and the new locations which are created will actually filled by 0. Okay, will be filled by 0. So whenever new memory will be allocated after certain block of memory, it will be initialized to 0, right? And whatever the previous memories are there, it will be remain intact. Okay, so that is the funda of the realloc function, that whenever you use the realloc function, you should know that how the reallocation will be done. Alright, so this is the thing that we are actually going to demonstrate, and after that just try to print it, and finally we can do another thing that is very major thing, that is the freeing of the memory blocks, that how you can actually free the memory. Okay, so if you run free then p1, then definitely what you can see, we can see that for whatever the memory allocation has been done corresponding to p1 will get immediately deallocate or immediately de-reserved. Okay, so if we write free of this particular memory, then definitely entire memory will be gone, entire memory will be get stopped. Okay, or it will be deallocate and the memory or data will be actually de-reserved. Okay, so that is the operation of the free function. Okay, and you may demonstrate after doing free, you can demonstrate or you can see that what will be the data available into your system. You can simply get a garbage value in that case, right? So we try to someone is asked, Saad Ahmed is asking real of p2, if we do then it should delete one memory definitely. Okay, if we try to squeeze it, then definitely it should deallocate the memory. Okay, Devashish, you are writing scanning p plus 1 means we are giving the address and how we are printing the value is start with. Yes, exactly, it is correct, Devashish. Sir, got GCC to stdlib for malloc. No, not extra class declaration, just alternative of the stdlib. Okay, alternative of stdlib is malloc here. Okay, so just try to execute it. So I'm just taking the data 1, say 2, 3. Okay, now see here, when you are taking the data parallelly, it will also showing you the data, right? Now suppose I am after doing this, actually the reallocation is done, so I'm just not giving anything, or maybe I'm giving the data like this 0. So see, previous data 2 is actually showing to you. Okay, after that say I'm writing 9, 8, so it will also showing the 8 that is already taken, and also it is showing the previous data which is 3. After that I am giving say 7, then definitely it will be 0 because it is newly allocated. So let me explain it in a detail. Previous equal to this I'm writing, okay, and current equal to this. Okay, so that you can easily understand. After free this. Okay, so now try to execute. Okay, run, take the data 1 is fine, then say 2 is also fine, then 3 is also fine. Now see, it is taking plus it is also writing previous equal to 1, that means previous data was 1, since that is resized, then also the value will be remain persist. So I'm taking some value, say 6, current is 6, previous is 2. Okay, previous is 2 means that's what I'm taking given over here. Okay, so that is 2. Suppose I'm taking another value 9. Now if I write 9, then previous say 3, that is we have given over here, so that is 3. Now suppose I'm giving 15. If I giving 15, then 15 is current value, previous is 0, that means what, it is a newly allocated memory location. Okay, where we are storing the data. Then suppose I am writing 18, then previous is this, that is there is no it is actually showing garbage value. Okay, then say 98, again it is giving say 99. Okay, so it is actually giving some zero values as well as some additional garbage value as well. Now sometime it might happen that due to the problem it might be giving some garbage value as well. Okay, so it is actually doing, and after doing this, after free, it is written after free, it will be actually showing you certain garbage value. That means since the memory get deallocated, so definitely your value will be also garbage. Okay, so that is the demonstration about the reallocate function. Okay, so this is up to this. So I think hopefully you understand all these stuffs. Now there may be some question answer session will be there, and your IEM selfie test is already given to you in the Google Classroom, and also your assignment is also given to you. So hopefully you have to do that assignment and then submit it to us. Okay, so thank you. We will meet in the next class again. So thank you very much.